Hello, my name is Joshua Min, and today I'll be presenting my research project, Harmonizing with Machine Learning, using AI as a tool to generate music. A bit about myself. I live in Dublin, California, and I'm a current senior at Dublin High School. And my project mentor was Eric Cheek. The idea for this project came from my passion in both music and AI. As a classically trained pianist and violinist, I was curious to see how machine learning could participate in producing classical music, which is often very sophisticated and can be abstract for models to learn. So first off, what is machine learning? Well, machine learning is the process of training a model based on a processed training dataset and using algorithms allowing models to learn and improve. There are a variety of machine learning architectures, such as CNNs and RNNs, which can all serve different functions, such as finding patterns or making decisions. This is an example of what a neural network looks like. Neural networks are a popular type of machine learning model inspired by the human brain structure. On the left of the diagram, you can see the input layer, where each circle represents a feature of your data, like pixel values in an image. And these features feed into the network. Now, moving on to the right, you see multiple hidden layers. Each neuron in these layers takes inputs from the previous layer, processes it by multiplying the inputs by weights, adds a bias, and then passes the result through an activation function. This process helps the network capture complex patterns. Finally, on the far right, the output layer provides the final prediction or decision, such as classifying an image as a cat or a dog. This flow of data from input to output and the adjustments made during training are what allow the neural network to learn and make predictions. The research question I attempted to answer was, how effectively can machine learning models generate music that replicates the style of classical composers like Chopin? So a bit about Chopin. He is a Polish composer who lived during the Romantic era of classical music, and his music was known to be very expressive and emotional, which is also one of the reasons why I chose him for this project. So I used the classical music MIDI dataset, which consists of 48 Chopin piano music MIDI files of some of Chopin's masterpieces. MIDI files contain instructions for what notes to play, and they are compact, and they're useful for machine learning as they provide structured data on musical elements, which enables efficient analysis and music generation. For my project, I used the LSTM model, which is a type of recurrent neural network, and this stores sequential data. And in this diagram, you'll see a cell state running horizontally acting as the memory. The input gate, shown as a node with arrows, decides what new information to add, while the output gate, another node, determines what to pass to the next layer. These gates control the flow, helping the LSTM remember important information over time. Now I'll be going over the model building steps. First, I imported libraries such as Music21, Matplotlib, and NumPy. Then I use Music21 to extract chords and notes. Then I analyze note frequency by identifying and removing rarely played notes. Next, I removed rare notes to reduce computational complexity. Then I translated notes into numerical representations of the process to the LSTM. Then I prepared the data by splitting into training and seeding data sets. Then I used two LSTM blocks with 512 and 256 outputs. And then I trained the model over 200 epochs or iterations with dropout to prevent overfitting. And finally, I evaluated the model by analyzing the training loss and also, of course, creating the final MIDI file. Okay, so now I'll be going over the training loss of the model. Training loss is the measure of how well a machine learning model is performing during training. And a lower training loss indicates that the model is making more accurate predictions. And as you can see in the table and the graph, there was a significant decrease from 6.035 to 1.0885 by the end of 50 epochs. Similarly, for the notes themselves, you can see that there was a significant decrease in terms of loss value. And we can see that by the end of 50 epochs, the note's accuracy was 86.35%. And also for the durations, there was also, again, a significant loss value decrease. And by the end of 50 epochs, there was a durations accuracy of 76.72%. Now we'll be analyzing the results. The song was in C major. It was in 4/4 time signature, and it was 120 BPM speed. We found that the music was very structurally sound, but it also lacked the emotional complexity of composers like Chopin, and the melodies were often simplistic. And there were also occasional harmony mismatches, but nevertheless, it was very enjoyable to listen to. And it also was found to have effective note duration handling. So some further improvements are exploring alternative models. So this could include experimenting with other machine learning architectures such as transformer models and GANs for enhanced music generation. And then we also plan to incorporate additional music elements, and so we can expand beyond melodies to generate accompaniments, harmonies, and percussive elements. We also want to diversify instrumentation by developing models capable of generating music for a wider range of instruments, not just piano. And finally, we want to enhance data quality and variety. So we can utilize larger and more diverse data sets, including non-Western and modern genres of music. Conclusion. So in conclusion, we found that our model had a lot of potential in terms of applications, which include collaborating with musical composers and artists to make better music. And we also found that it could advance the creative potentials of AI, as it also allows for democratization of music production. Thank you for listening.